Hello and welcome to another video. And in today's video, we will talk about the feature engineering. In my previous videos, we talked about the data acquisition and the data preparation as part of the generative AI pipeline. And in this video, we will talk about the feature engineering, or basically that how to extract features from the given data so that we can do the prediction and we can generate some new content using the generative AI pipeline. So the first thing we will discuss is that why do we need to work on the feature engineering and why is it a little bit difficult and different from the machine learning or the deep learning models. So if you already have taken the machine learning courses, so you can recall that the data that we have been given using the in order to process with the machine learning model, mostly it is in the text format or in the tabular format. So for example, so here we have, let's say, let me change the color, 1 second. All right. So for example, we have here different columns. So let's say we have text data in Excel format. So it has three, four different columns. All right. So the first three columns, for example, column one. So the first three columns, for example, we have column one, two, and three. So these are the input data, and the last one that we have is the output data. So I will just denote it by y hat. Okay. So that is the output data. Okay, so for example, let's say the model we have is that we need to predict that the person should be given the loan or not from the bank. So the input data, for example, is the salary of the person. So let's say it is 10,000 salary, and the location, any particular city. Okay, and the third parameter could be is the person married or unmarried? So that could be the third information. So this is what we have in all these different cells. And then the output is whether the loan should be approved or not. So it would be either yes or no. So approved or not approved. Okay, so that would be the output. Now this is the data and it has the fixed length. So this information, so for example, here we have the machine learning model. Okay, so this is the machine learning model. So it will have three inputs. It will have three inputs, the column one, two, and three. Okay, so these will be the inputs, and then it will generate one output. Okay, so the column that we have is y hat. So this is the output column that will be used to train the model. Okay, so if we look at the input data specifically, so it has fixed length. It has three columns, so it will have three input nodes, or we can say that it will have three input parameters. So all we can do is we can just increase the number of rows. Okay, we can increase the number of rows, but the input parameters will remain the same. So it will always have three input parameters. So this is what happens in the machine learning or the deep learning models. So now if we talk about the generative AI. Now, the generative AI mostly works on the unstructured data. Okay, and if you have worked on the Chat GPT or any other large language model, so you are giving the input as the prompt in the text format. So, like any sentence. Okay, so for example, there is a generative AI model. For example, so here we have, let's say, Chat GPT. So here we have the Chat GPT, and it will take the input and it will generate the output. Now the input, for example, we are writing a prompt. The first input, for example, is hello Pakistan. Okay, so this is the input. Okay, so this is the length of the input. So this is the input parameter. Then in the second prompt, you are giving, for example, my name is Amir. Okay, so we can see here that the input parameters are different. The length of the text is different, which means that the input parameter is different. Now, this is the problem, that if we continue with the machine learning terminology, or if we continue with the machine learning methodology, so this will not work. So we need to fix this issue, that even if we have different input fields or different parameters, the model should accept that those parameters and should generate some output. So for that purpose, we need to work on the feature engineering, as far as we are working with the generative AI pipeline. And in order to work with that, there are different techniques available, which are coming under the text vectorization. Okay. So text vectorization, which basically means that we need to convert this particular text into numbers. And the reason is that our machine learning model, okay, our machine learning or the generative AI model can only understand numbers. Okay, so it is not able to understand these text as it is. So the purpose of the text vectorization is to convert the text into numbers. Even if we are using the machine learning and we have different text, so we need to convert those text into numbers as well. So wherever we have any type of model, it only recognizes the numbers. So under the text vectorization, there are different methods available, but one of the common method which we have available, that is called the bag of words, okay, or BOW. Okay, so that is one common method available for the text vectorization. Okay, and the text vector under the text vectorization, the BOW mostly is used for the sentiment analysis or a review. So sentiment analysis means that if you have if there is a movie and people will comment on that movie whether they like it or not. So if there is a sentence that okay, the movie was very good, so the using the bag of word text vectorization, we can easily identify that it was a good comment or a bad comment, or it was a good review or a bad review. So mostly for the sentiment analysis or for the review analysis, we can use the BOW or the bag of words. So that is the little background, that why we need to work on the feature engineering and why is it little bit difficult than the machine learning algorithms. And the reason is that because in the generative AI, we are mostly working with the unstructured data, which means we don't have any fixed length of the input parameters. So in order to cover up with that problem, we need to work on the text vectorization. And under the text vectorization, one of the common method we have available, that is called the bag of words. Okay. So now we will see how to perform the bag of words. So now we will look at the details of the bag of word, how this method will be working. So just ignore all of this text here. Okay. So for example, we have four different input prompts for our generative model. So for example, we have, let's say, D1, okay, and then we have D2, D3, and D4. Okay. So this, for example, is the first column. And then in the second column, we have the prompt itself. So I will just write the prompt. So let's say the first prompt we have is uh, Lahore is in Pakistan. Second prompt is, let's say, Pakistan is in Asia. And the third prompt we have is, let's say, K2 is in Pakistan. K2 mountain is in Pakistan. And the last one we have is, let's say, okay, Amir, PMP, Amir. Okay. So let's say these are the prompts that we have. And now we will see that how the bag of word mechanism works whenever we are working for the generative AI models. Okay. So to begin with, what we need to do, we need to first extract the unique words from all of this data. Okay. Now all of this data, starting from here till the last, all of this is what we call the corpus. So that is the corpus we have for our generative AI model. And from this corpus we need to extract the unique words. Okay, so the unique words that we have here, so let's create a table for that. So the first one we have is Lahore. Okay, then the second word, okay, is in Pakistan. Okay, then this already has covered, is in already have covered. So Asia next is the unique word, and then we have K2, then Amir, and the last one is PMP. Okay, so this here we have is a list of all the unique words from the corpus that we have. Okay, all right. So the next thing we need to do once we have obtained the unique words. Now again, while working with the Python will be working automatically on all of this corpus, that how many unique words there are, that we will see in the next example. But this is how at the background all of this bag of word technique will be working. Okay, now next thing we need to do is we need to work on the frequency. Okay, because the bag of word is a frequency based model, so it will look at the frequency. So the first prompt that we have here at the top, Lahore is in Pakistan. So if we look at the frequency, that in the first prompt, so here the first prompt, how many times Lahore came, so it came one time, is one time, in one time, Pakistan one time. And in the first D1, Asia K2, and they were not there, so we'll just write 0, 0, 0, and 0. Okay. Then in the second prompt, we okay, Lahore. No, we don't have Lahore. Is in, yes, we have is in one time. And then Pakistan, yes, we have Pakistan one time. Then we have Asia, yes, we have one time Asia, and all others zero. That is in D2. Then in D3, excuse me. Then in D3, what we have same thing, 0, 1, 1, 1, 0, 1, 0, 0. And in the last one, we have 0, 0, 0, 0. So all 0 except 2 and 1. So here we have in the last sentence D4, we have Amir coming two times, and we have PMP coming one time. All others are 0. Okay. So this is the matrix that will be created using the bag of word technique. So again, this is the whole corpus that we have, and these are the different prompts. And from the whole corpus, what we will do, we will first create a table of all the unique words, and then we will take the first sentence and we will check that how many times each word is appearing. So if it is coming only one time, we will just write 1. If it is not appearing, we'll just write 0. And for example, in D4, Amir came two times, so we will just write 2 here. Okay. So that is how we will create the matrix using the bag of word. So what it will do, basically, it will allow us to look for the frequency. Okay, it will allow us to look for the frequency, and we can then identify whether a prompt, whether it's a good analysis or a bad analysis, or if it's a good sentiment or a good review or not. Okay, so that is the whole purpose of using the bag of words. So for example, let's say we have a sentence, uh, this is a good movie, I like it. Okay, so that is the review. Now again, it will try to find out that how many times the words are appearing. So we have good coming one time and liked also coming one time. So both of these words recommend that it's a positive review. Or for example, if there is a review, for example, this is uh, a bad movie. Okay, this is a bad movie. And then continuing, and we will say that, okay, bad music. Okay, so it will look for the frequency. So here the bad will be coming two times. Okay, so it will help us to identify that it's a bad review or it's a bad analysis. Okay, so that is the whole purpose of using the bag of word, that it's a frequency based model. Okay. And so that is how this will work. And next we will see using the Python that how we can implement the bag of word technique. So now we will see how we can work on bag of words using the Python. So here we have the Colab file on the Google Colab. So the first thing which we need to do is to import the NumPy and Parnas, because we'll be working on the data. And then, so let me execute this file here. And then the second cell we have here is we are creating a data frame. And in the data frame, we have the same data that we just had a look in the previous and in the data frame, we have the same data that we were working on. Lahore is in Pakistan, Pakistan is in Asia, and all the other stuff. So this is the whole corpus that we already had worked with. So we need to execute this frame. So the data frame will be created here. So as we can see, this is the data frame we have. So this is the first one, first row, second, third, and fourth. And we also have the second column, which is the output column. So which basically gives us the idea whether it's a good review or a bad review. So I'm just writing some sample numbers. One means a positive review, and zero means the negative review, just as example. Okay. And then we will go to the next cell, and we will be importing one library from the sklearn, which is called the count vectorizer. So count vectorizer basically is the bag of word. So it is another name of the bag of word, the count vectorizer. So once you have executed this cell, then you need to execute the next one. So what we are doing is we are creating a variable BOW, and we are fitting the data into the count vectorizer. And in the data, we are just taking the text data as an input. So once this is all done, and then if we execute the next line, so you will see the whole vocabulary. So this basically is the whole corpus. Now here the interesting thing is that it has given some index number to all of the unique words, and this is all done by the Python itself. So for example, in the sequence of the very first word we have is Amir, which is having 0 as the sequence number. Then we have Asia, which is having 1, and 2 is here in. So this is all the index numbers that has all been given by the Python. Now it will exactly do the same thing which we saw in the previous slide. So for example, if we look at the first word in the sequence, which is Amir, and then if we look at the first row, so here we can see, okay, Amir, is it available or not? No, it is not available in the first row, so it will allocate 0 here. Then the second is Asia. So Asia, no, it is not in the first row, so again you will have 0. Then you have this token in. So in is available there, yes. So it will allocate 1. Then you have 3 is, yes, is also there, so it will allocate 1. And if we go for 4, which is K2, K2 is not in the first row, so it will allocate 0. So what it will do, it will start this sequence for each and every line, and it will check whether this particular token is available in that particular line or not. If it is available, it will allocate 1. If it is not available, it will allocate 0. So this is how this matrix will be created. So again, it is all based on frequency. If a word is more than one, so it will allocate that frequency in the index table. So once this has been done, so we can also execute this line. So we will see that this particular array will be created. And then in the next one, if we execute this. So now, for example, what we will do, so once we have all of this index created, we can just give a new prompt to our model. So for example, Amir PMP Pakistan. Okay. So if we execute, so we will generate, we'll be having an array. So whether a word is available or not in the whole corpus. Now, for example, if we give a different token which is not available in the vocabulary, for example, I will just add 1, so Amir 1, PMP 1, and Pakistan 1. Now, these words are not available in the corpus. So if we execute this line, so we will get all zeros, which means these words are not available there. Okay. So that is one important concept, is that if we have this kind of situation, so we call it the out of vocabulary, OOV, which means that these words or some of these words are not available in the vocabulary. They are not present there. Okay. So again, we need to make sure that we are signing or we are submitting the words which we have available in the whole corpus. Okay. Otherwise, we will have the out of vocabulary issue. Okay. So this is how basically the bag of word technique works. So whatever new prompt or whatever new tokens you will submit, so it will compare that against the whole corpus and it will show you the frequency of those numbers. And based on the frequency, you can then determine whether it's a good review or a bad review, or you can also use it for any other use case as well. So that is all about for the bag of words.